First of all, there isn't one way of computing on topological spaces, contrary to the popular opinion that everything's just a Turing machine. So, let's think about computability on the real numbers, but just the computability on the real numbers seemed a little bit boring. So then I started thinking, what does it mean to compute with points in a topological space in general? What kinds of topological spaces can we compute with? And it turned out, of course, that there were lots of people before who thought about this. And there were what people called several schools of computability, like computable mathematics. So there was the Russian constructivists from, 1950s or so, where they did everything with Turing machines. And then there was what was called the Type 2 Turing machines. This is Klaus Weyrauch's school, a German school, where they set things up in a different way. Then there was domain theory, Dana Scott and domain theory. That was also one way to do this. And as I started to learn about all these ways to explain what it means to compute on on more general topological spaces and metric spaces. So the kind of thing you have to have in mind is like, okay, I mean, if you compute with real numbers, then presumably you're doing some sort of intervals or approximations to a real number, and you're somehow calculating these approximations. But when it comes to a more topological space, then you should have in mind maybe a more complicated space, like some sort of a surface, or even a function space, or an infinite dimensional vector space, and more complicated abstract things. And the question always is, well, what does it even mean to compute on these things? And so as I learned about the different ways that people have approached this question, it became clear that these are all facets of realizability models, that these are just different realizability models. And so in my thesis, it was, to some extent, it was a kind of a synthesis that said, look, there's a system to this. It's not just the German school and the American school and the Russian school. These are really mathematical, these are just aspects of realizability.